wondering if someone can run and buy another box of coffee somewhere. Is there a Starbucks close to here?
Yeah. I don't have my sign-in sheet, or I would go do it, but I'll check with somebody when they come in.
My buddies down in Arizona.
Yeah.
He said, I just got cut off by a Maserati. You should know. The only time they know me is when we miss
Maserati comes up. As expected, nice.
Yeah.
Warm.
Hey, good morning. Like the shoes with the suit.
Thanks. Treating some tender feet.
You didn't have any problems getting in and out with all the weather here? Oh, that's good.
Any of you, I don't think we have enough coffee for the morning, whoever bought it. Any of you authorized to go buy a box of coffee at Starbucks?
Yeah.
You know what Starbucks is?
Yeah.
He's got his
So
running,
one
he's got his
time-
running shoes
So
on.
one time I brought my own though.
He's like, you can,
Usually I've gone there.
you can order a drink while you're there, too. That's the good part.
Okay. Whatever it
Thank
says.
you.
No problem. Just grab a thing up.
Just one of these,
Crap.
yeah. That'd be great.
They're fast out of that little Starbucks down the street, too.
Who do you prefer for the morning, Dr. Altman? What?
I thought we sort of had a standardized order. Doesn't Christine?
We switched last year from Panera to specialties because
These
they're more
people
reliable.
are more reliable. That's
Yeah.
for sure. What's
Yeah.
the order?
Yeah, and they're close. They're just like 2 blocks down the street.
Who is specialties?
Yeah, they're close.
Can you order stuff online?
You can just do it online. It's really easy. I've had, last time I did it, they forgot the coffee. I had to run down to Starbucks. So what I'm going to do next time is just call the night before and make sure they've
Who's
got it.
responsible today? Do you know?
I have no idea.
I don't know.
I was gonna-
I've got next week, so I'll make sure to order 2
Yeah.
travelers.
Well, no, I think it'll.
Yeah, it's better. Just
The thing that's ironic is it's never the same driver. So you think that this early in the morning they would have
like a routine.
yeah, but it's never.
Yeah, I remember last year we had 2 issues.
They would deliver to the month or the month.
I just did training yesterday, and I didn't do the ordering. Here was we get about
Yeah.
Morning.
From themselves too, which is really kind of a fun lunch. I mean, like that's true. They get lunches anyway.
I used that easy cater.
Oh, that's good to know. That's good to know.
So I would say if they're not giving an option,
Yeah.
put down like at least 30 minutes before you want
Who do you use up in Alaska?
I used Easy Keeper
Oh.
because I couldn't find nobody. The other one that is pretty good is Peanut. It's
Try
there.
that.
I think you can order direct from them and actually deliver. They have like these really nice boxes. They're like platters, but they're all everything's disposable.
tip. I've used twigs because that's what they recommended at the allergy office up there. And they're pretty good, but I mean, they can get expensive depending on what you order. I mean, I think my last lunch was like $84, so I thought, oh my god, my boss is gonna.
Yeah.
But
For the domain office.
you know, who knows where this guy's little place is? He says he makes everything homemade. He did like chicken parmesan. I mean, it was a delicious lunch. Yeah, Alaska's tough. I don't know where everybody's going to park here today. The parking is horrible.
Was it like this last week too?
I was there last week. We've had so many meetings, and I have Alaska too, and Bellingham, so it's, I feel like I haven't been here in a while.
Since they started back, I think they've only made it to a couple.
Yeah.
Is this your last year, Dr.
Oh, yes.
Nice.
So excited.
Oh,
Home
yes.
stretch.
What'd you decide to do? Are you going to go back east or
No, I am.
stick around here?
I was going to Bellingham.
Oh, you love Bellingham. You'll love it up there.
Go to St. Joe's? Or
No, with David O'Kayam.
that's rad.
Thank you.
That's a good office.
They're really nice. They're so nice. I was up there just a few weeks ago, and I saw like deer in the parking lot, and
In the parking lot?
yeah, I don't know. I mean, I don't know what was going on. Snow, but
I was like talking to one of the PAs, and she was like, "Oh yeah, I have bobcats and mountain lions in my yard all the time." And I was like,
don't watch out for your small dog, your cat.
"All right, well, there's wildlife."
That'll be good. He
Yeah.
does, I think he's starting to get back into doing infusions in his office.
He is doing infusions.
Yeah, okay, yeah, because I know he stopped for a while because I think reimbursement was really bad. So.
He was doing infusions. I think he was able to negotiate with at least group health. Well, yeah, he's getting through the consortium, and I think he talked about contracts with group health and a few of them, not Blue Cross, and he was able to get favorable.
Well, that's good. There's a lot of group health up there.
There's
It's
a lot
like,
of group health.
yeah,
It was about 25%.
yeah, it is.
But yeah, he was able to argue sort of on based on the facility fee, the hospital charges.
Yeah, done.
Which
Smart cookie.
Well, and with that CARES Act, that's going to be really good
Yeah.
because Medicare is reducing their reimbursement for home sub-Q, for PI, for durable medical equipment.
Oh,
So
interesting.
they're reducing it for SPPs.
uh-huh.
So that'll be a nice alternative for those patients where,
Well, he does say some people sub-Q in the office too. There's
Yeah.
a handful of people who just refuse to do it.
Yeah, well, and it might be even more in his office.
After this.
Yeah.
Yeah. Agreed. Interesting. Well,
Yeah, he's one of our consortium docs.
Yep.
Has, special pricing on stuff. So,
Yeah, he's big into that.
yeah.
Jerry, when you go to Fairbanks, do you fly direct? Or do you go to Anchorage first? Yeah, I try to fly
Well,
direct.
I try to find, yeah, sometimes you gotta mix them up. But,
Yeah. Hi, how are you? Good, how are you?
Yeah, I always try to be here first, and then I may spend the rest of the afternoon, let's say in Anchorage.
Yeah.
Okay, 'cause I can get up there
Usually
with all the flights.
Yep,
And tomorrow I will fly up to Fairbanks
yep.
and spend the whole day, maybe half of the next day. And then home, but this time, not days.
Yeah. I know, I try to change it up a little bit too.
It's
Do you go to Soldotna?
It's just start ready by the end of the day.
Yeah, I need to go there.
Oh,
I
Well,
almost,
I
I really
have
won't bet you that.
head, so I'm
I know.
it's kind of funny because she's so nice at the conference.
I don't know, it's pretty
So nice.
extreme.
In the summer,
That's the last thing I want to deal with in this clinic or something like that, but I email her yesterday.
Nanny isn't the greatest in the world. That's what, well, one's helping out today.
She's not going to.
Oh, is that right?
She's too sick to go free soon. Somebody upstairs. Seventh illness? I don't know.
Good morning. Sharp. You're sugar club. Can you show up in your jeans?
He's got a tie.
Yeah, I could right now.
I'd be here in Levi's and a t-shirt.
You want to get a good tax break.
That's right.
How are you?
Going, you ready for your trip?
Yep. Actually, in the afternoon. It's a red eye. We go to Frisco first and then to Sydney. It's a killer. That's right. It is. When he got a little extra leg room and stuff, so maybe not quite so crowded as usual, coach, but.
We've been looking for that
So I can take
trip.
that
We have to go to
I have a subway home at night.
maybe actually paying for business or first class.
Because you have enough miles, that's probably the best way to swing
The trouble is, we have enough miles that they offer, so even if you have 100,000 miles to spend, it's still good to you can go, we bought a, say, Delta connection, you can go to Amsterdam, then Amsterdam. You have a last, they make you go like San Francisco, London, make you wait a long time between flights. They don't offer you an ideal connection.
Yeah, I might sneak out a little early. I came here, I got 20, 25 minutes early. I couldn't find plus I'm in a motorcycle, so I'm hoping.
You don't have to do it now. Hi, how are you?
Alex Drew said he got here like where I'm still couldn't find parking.
I'm down on the lot.
That is a big nuisance. So.
Let me make a comment here, but I'll talk to, there is a garage under this building.
I remember parking in, across the street on this building, and I did it 2 or 3 times. Then I started coming so early I could get on the street, but now it's a nuisance. It's a...
It's terrible. You're parking under it?
There is.
Old timers.
Talk to Francis about,
Yeah, especially when I bring food. No, yeah, we just missed it.
What did you guys come to us a few years ago?
Oh, awesome.
I don't know it's going away anytime soon.
Pretty warm. I don't care. I'm just kind of there.
There you go.
It's gonna help.
Yeah, it is the...
Figure this out.
Take a selfie or something, yeah.
Sign my name. I'll
And that's not your fault. I don't blame you. It's just the city is just a mess. So
It's just this one.
Oh, so
I
nice.
don't know what's going on. It's all the construction. Have you done that? Seems like
Well, that's what was nice.
Yeah.
I was
be there.
like,
I didn't even try to travel right away.
Yeah, so I will be sneaking out early. So I don't get my car towed. I don't think it's
I saw Jerry, he's parked.
pretty much.
wow. Go full sushi today. And yeah.
You
Yeah.
don't have parking, that's all. It's like
How much?
You write your Francis.
It was a change. Like 3 or 4 weeks to stay with us.
And $5 I would
After a week,
Oh, yeah.
That's so great.
Okay, this vacation.
Trouble used to be that
It's pulling it together. I really know what it is. Yeah, now I got stopped at the gate, I couldn't get in. And then you talk to somebody, and they let you in, but it's still...
Bill would know more. I'm not really good at that.
Sometimes actually like it. Like it's really, I would wear, but
If there's any late left, I'll take it out of the We gotta figure something out here.
Probably not much.
Now that bridge, of course, has been closed.
Well, they case because of the chit-chatting.
They'll open
You're
it
parking.
to
Parking
temporary
music
green, so
going.
they have
Okay.
that flag spot off of the regular green. They don't want you one of those greens. It's not just what was that? When it was cold.
Oh, yeah. Montana. Several days last week in our neighborhood.
In August, right? So.
So last week, I started to come here with throat
And I just found
No,
black ice.
they had this like fair sale.
I couldn't get out of our neighborhood.
So we're going over there, but it's like $50. That's
How much was your
I think they're at C123. They were similar to here. It wasn't as actually about 100 calories. Good morning. Happy New Year. How are you?
It's like the AV equipment's working. I'm part of it.
You can't exactly.
4 years in a row.
No, I got here. It's the payback. I was saying.
By the time we get there, then we
I just said this to I just remember that call from you. It's like 17, so I'm at home. My kids.
Frank? I'm just hoping that the meter maid won't be out until 8 o'clock.
Yeah, I know.
Well, you need a record
Everything.
time.
It's not.
It was the shoes.
It was the shoe.
So well with your suit.
I love it.
Well,
I mean, right from here.
Yeah,
Maybe
I know.
look at that.
now he'll take the bus and show up on 2 hours later.
I'm fine doing that, honestly.
No.
I'll see you guys again. That's good. There's only 11 people sick.
over this next 3 weeks, I'm going out tomorrow.
No, it's not.
Yeah, well, we're going to Draper, Sydney and Draper. We're going out to
Who changed it though? Did Suzanne do it?
It is crazy.
a long trip to get that far. It's a cruise.
How are you?
Crystal.
Right. How's that one?
Yeah, we went to Southeast Asia, but they're very nice cruise lines. They're not the most expensive. The ships are all. That's right. About 600 pounds.
600, so it's not like,
No, it's not one of the big boats. It's about 600 passengers, maybe 700. Crew is about 600. But it was just so far off the beaten path. It was the first time this itinerary. Probably not developed at all. A lot of those places are diving. So a lot of tropical islands. And also the Indians are very primitive area in the world. There's one generation of headhunters there. Yeah, it does that, yeah. But it's a 3-week trip, so I'll mark it in case you have to say I fish, but I just went quarter wrong. The car's still there.
Oh, okay.
I drove around Block 3 or 4 3 times at least. That was the only thing. And I looked at it like, oh, you shouldn't do that. Get towed.
Can see it. But I was like, oh, I'll be happy with you now. Pretty much.
Let me send you
Cool. Try that. Let me just make 2 quick announcements before we get started. One, for those of you who know our colleague Jeff Maine up in Anchorage, he's been ill and out of practice now for a number of months and looking at a couple more. He had back surgery and I think he's got osteomyelitis. He's having a really rough time. So for those who know him, fellows who have worked with him and gone up to the conference, just a thought or an email or something would be nice. It's really been a rough go for him. A much more mundane thing, the parking here has become insane. So I'm going to talk to Francis in the office, see what we can do to get the garage either in this building or the one we used to work in across the way open, and see if we can cover parking or something, because you got to park blocks away, and Jerry parked illegally. They towed his car already this morning.
Thank you.
Jerry parked illegally.
I'm parking
So those
motorcycles.
who come by bicycle.
Okay, I'm going now and move my car.
No, it's fine. It's been towed already. Where'd you park?
It's not really tollways.
Yeah, because they cover my, if you have barbecue parking or you don't parking, they pay.
Most of the guys here don't have that.
Right.
So they have to find street
I
parking.
don't know how much it costs to market.
Well, that's one of the perks of being on faculty.
Yeah.
Okay.
Not really.
All right, anyway, let's go ahead and get started. John Lynch has given us, this is your 5th year?
6.
6th year?
6.
Yeah. Obviously, we're slow learners. So our annual update, infectious disease for allergy.
Thank you so much. Good morning, everyone. Happy New Year. Thanks for inviting me yet again. Every year, as I say, I come here and do this, and I basically just talk about whatever I want. It's not really an update, so to speak. I did go through, actually, pretty carefully PubMed searches for allergy and infectious disease, immunology, and infectious disease. You can imagine there's huge overlaps in many of those things for all of 2016. And there wasn't like a huge number of updates in terms of clinical allergy, immunology, and infectious disease. So again, I just went out on my own little tirade and some updates here. And I always finish this, I always go put too much in because I love infectious diseases. And so this year I tried not to. I'm going to try to not pack it all in and finish actually on time. And again, as always, please stop me and talk. I'm happy to talk about any of these topics or any of these questions as we go through it. Your input keeps this lively. And I know you guys always have great comments and questions. And there's certainly experts in the audience who comment on some of these things as well. So first thing, no disclosures. So one of the things I thought was kind of interesting and fun, I did come across a paper on the living croquet theory when I was going through a review over the past week or so. These are two sort of guiding hypotheses in infectious disease, and I think that the second one just came up.
And these are both come from Lewis Carroll's work, Through the Looking Glass and Alice in Wonderland. And so it's the contribution of Lewis Carroll to the understanding of infectious diseases. The first one is the Red Queen hypothesis. For those of you who remember the Red Queen, she made that comment about you have to keep running faster and faster in order to stay still. Remember that comment? And this is an idea in infectious disease that's been around for quite a while, talking about how an infectious disease mutates through time, and influenza shifts and drifts, and our immune responses have to also accommodate those. So we're in this kind of continuous battle of infectious disease with the pathogens mutating and changing and adapting to us, and us adapting and changing and mutating in order to accommodate those things. And this actually has wide-ranging implications in infectious disease, because you can imagine it applies to pretty much any pathogen out there, at both the specific pathogen level, but also sort of population level. When you start thinking about some of the newer pathogens that are coming up over the last year, something that's is kind of unexpected is a new fungal infection, Candida auris, which is pan-resistant to most of the drugs we use. This isn't something we know that we created. This is just something that just appeared and is now spreading around the world. It's pretty amazing. The second one is a newer paper. This came out by a little comment written by a guy named Didier Raoult, who is a very prolific infectious disease researcher out of France. And he calls it the living croquet theory. And this also comes from Lewis Carroll, as I mentioned. And the point here, again, for those who don't remember, there was a part where they were playing croquet, all the actors in the book, but they're using flamingos and flamingo heads to hit hedgehogs that are little rolls. And the idea he was saying is that we make all these predictions about what's going to happen in infectious disease. And his really nice example was back in the early 2000s. MRSA is here to stay. It's going to take over everything. And in fact, that was the scientific, I thought, was that was going to happen. MRSA is going to replace MSSA. And what actually happened in Europe, and actually has happened in my own practice here in Seattle, is that MRSA, in many things, sort of trended away and down, even though we were using antibiotics in the same way, if not more, than we had in the past. And his point was that when you go to hit a hedgehog, with a flamingo head, flamingos turn their heads, hedgehogs get up and walk away. You can't actually predict what's going to happen. You don't know what's going to happen. Like you think in croquet where you hit a perfect ball and it goes somewhere. So basically the idea here is that everything's changing, and everything I'm saying probably actually has no meaning. Because I can't predict. We don't know what's going to happen. And it's actually one of the most interesting things about infectious diseases. So if anything that you walk away with in infectious disease sort of update are these two ideas. Okay? Because it's what makes it interesting. And you can thank Lewis Carroll. So last year I talked about Zika Virus update. That was a big deal last spring. Continues to be. I tried to talk about antibiotic stewardship and the Allergist. I think I started to run out of time around Clostridium difficile. So I just have a couple slides on that. So I talked about the last two. This year I'm going to talk about a little Zika Virus update because I think it's really important and newsworthy. I'm going to talk influenza again because there's some really interesting work on the immunology side, the vaccine side, as well as it's in Seattle right now. Ebola virus update. There's a really nice little paper on otitis media that came out in the pediatric literature, and how that goes against or goes with or hand in hand with antibiotic stewardship. And then, as I mentioned, I didn't get to the C. diff thing last year, so I'm going to touch base on that today. And actually, I did add a little bit on some of the new drug resistance that's out there, because that's really important. So Zika. This is February 2016. I think around the time I gave this talk last year. At that time, we had 258 travel-associated cases in the United States, no locally acquired cases. In U.S. territories, locally acquired, that's mostly Puerto Rico, but some other areas, 283 cases. So that's 1 year ago. As of now, in the United States, we have 4,166 cases. Most of those are travel-associated. Big difference there is the locally acquired cases, 216, and a larger number of sexually transmitted cases. So when I talked to you last year, I don't think we were even talking that much really about sexual transmission. Outside of the places where this epidemic was rampaging, mostly South and Central America. But clearly there's been a number of people in the United States who have been infected while living here with no travel, and not from areas where there's transmission going on. And obviously the locally acquired areas. These have been really limited to parts of Florida. I'll show you some maps on this. And on the border of Texas and Mexico. And then more importantly, on the U.S. territories, 35,000. So at this point, in this hemisphere, we're talking about hundreds of thousands, hundreds and hundreds and hundreds of thousands of infections, and recrudescent infections actually in South Asia. So it's moved back there and is blooming there as well. So this looks like a virus that continues to spread and cause a fair amount of havoc.
Do you think those are an underestimate? Because a lot of people are asymptomatic.
Yeah, absolutely. So I think that's a gross underestimate. And I think those hundreds and hundreds of thousands tend to be more of the predicted numbers. Again, going back to the living croquet theory, we think hundreds of thousands, and I think, as pointed out nicely, is only about 1 in 5 people with Zika have symptoms. And so it's even a laboratory confirmed is 1/5 at best, probably even less than that, of the number of cases that are truly out there. And it's actually one of the things I think that's contributed to the epidemic is that if you are feeling fine and you're viremic with Zika and you're out walking around, the chances for you to get bit by a mosquito, which is then going to transmit that virus to the next person, or to sexually transmit that virus to another person, is much greater, I think, compared to something like that puts you down. Most cases of dengue make you quite ill, and you're going to stay home. Most cases of chikungunya make you ill, want you to stay home. Unlike Zika, where you're out walking around feeling fine. So, pretty big deal. But the big thing, obviously, that happened after I spoke to you last year was the CDC, for the first time in many decades, declared a travel ban on a part of the United States due to infectious disease. You guys, there's Miami Beach, and there's 2 areas.
Should be a pointer on this.
Oh, that's right. I was forgetting that. I have to wiggle it, right? There we go. You can see there's a couple of different areas here in Miami Beach, which is obviously incredibly populous. And what kind of made me chuckle a little bit. Obviously, this is not a good thing. There's about a 1 square by 1 square mile area there. This is Miami Beach, and obviously, and then the mainland over here. Is that somehow they're able to isolate local Zika transmission to a 1 by 1 mile, area of Miami, which is, I don't know how in the world that works that way, but that's what they said. And what they said is, you really recommended not traveling there if you're pregnant. What was interesting about this as well, from the infectious disease perspective, and this we saw this play out to a certain extent with the Ebola epidemic, is that the CDC and other public health authorities said, don't test people unless they have a travel history, right, and symptoms consistent with some sort of exposure. This was discovered because frontline doctors said, this looks like Zika. I don't know you didn't travel, but we're going to test you anyway. And this ended up being a kind of a bigger deal because, again, when public health authorities are trying to do the very best they can, often are the gatekeepers for testing for new infectious diseases like Zika, like Ebola, and other things. Actually, the mumps epidemic that's going on in King County and Pierce County right now. They really want a nice case definition. They want a nice set of epidemiological characteristics that kind of allow them to do the testing they think appropriately. This was discovered because the people who were initially tested met none of the criteria for testing by public health authorities, but the frontline folks went ahead and tested them. On subsequent tests supported the positive results and showed that there was local acquisition. And obviously that led to this travel ban. I would like to point out, you can't see it down here, but down in the Keys, down here, we do know there's been dengue transmission. I don't think any of these cases have been caught acutely. People present with dengue in many different ways, often can present sort of like a flu-like syndrome. But in sero studies showing that there's been a fair amount of dengue transmission down there. So, why it didn't appear in the Keys and ended up being up here in Miami Beach in this 1 square mile area isn't entirely clear to me, when there's this whole lot of area between the two, other parts of the state that are allowing. And we don't know why dengue and chikungunya haven't made it up there. We don't know why all 3 of these viruses that are transmitted by the same exact mosquito haven't moved farther up into Florida from the southeastern United States. Part of it's air conditioning. Part of it is that all 3 of those viruses tend to prefer poor people, so people don't have screens, don't have air conditioning, don't have access to insect repellents. But there's lots of folks who meet all 3 of those criteria in the southeastern United States. So, interesting.
Is the test PCR based?
Yes. Yeah. This is just a close-up of those 2 sites. And I've never really been to this part of Miami Beach, but I heard or Miami, I should say, but I've heard there's a lot of very wealthy people there. So, must have freaked them out, I can only imagine.
The South Beach.
South Beach. Have you been there?
Yeah.
I've heard of it. I don't know. It's like Beverly Hills, right? It's like, yeah.
We can only hope.
I assume they just put a giant net over the whole peninsula.
Is Florida the only state that...
So, Brownsville, Texas, which is down in the very south United States, there is a case reported there, and there's a travel ban associated with that area as well. This was a little tricky, so I've actually talked to some of my colleagues who do infectious diseases in Texas. And the report that's out of the public health folks have shared is not entirely clear whether this person who got Zika here, the Brownsville area, here's the Texas-U.S. border, is this like brown line right here?
Is that the map, the wall?
Yeah, this is the wall. Can you see it? Yeah, it's about a mile high, all the way through here. The perfect wall. Yeah. Thank you for doing that.
We're only a couple of days away.
Don't worry. I'll just try to be good. I know this is broadcasted.
Yeah.
Yeah, and so and it's not entirely clear. They haven't said clearly that it's what didn't have to do with sexual transmission, but it is on this border area, and we know there's transmissions going on in Mexico. So again, another area that's been affected, unsurprising this area, and we know that there's areas within the southern United States, including parts of Texas, that certainly meet epidemiological conditions for transmission of Zika virus. And as mentioned, the Anopheles mosquito that transmits chikungunya, dengue, and Zika are all throughout this area. So again, we'll have to sort of see what happens. No one sort of expected this, and again, when we get to my early hypotheses, the living croquet theories, that I can't tell you exactly what's going to happen. I don't know why two of these viruses haven't done it, and one has. Why it hasn't gone farther? Unclear. Yes.
There's some talk about putting genetically altered mosquitoes into these populations to try and kill them off. Is that going anywhere?
No. So there have been live experiments in village areas where either irradiated males or genetically modified males who are sterile have been released. And the idea there is that there's mating with them preferentially, and you decrease the mosquito population. I think it's been done. It has worked. One of the issues is that people are afraid of genetically modified organisms being released freely in the environment. On two, it's not a one-time thing. You have to keep doing it because mosquitoes will just move in from the other parts. There's the other one that's really cool. So there's the irradiated ones, the genetically modified ones, and there's ones that actually genetically modified that are sterile that smell really good, I guess, to female mosquitoes. So they make these like super pherogenetic mosquitoes that just attract females like mad. And those all, I think, have shown some efficacy, but no wide-scale applications. The key thing continues to be, wear insect protection, long sleeves, screening, and wide-scale pesticide use, which does work very, very well. So super cool. Zika in pregnancy in the United States. So 1,092 infections in pregnant women. This is the population that we worry about the most in the United States. This is data just from the CDC last week. 875 completed pregnancies, 36 live-born infants with birth defects, and 5 pregnancy losses with birth defects. So about 40 out of that 1,292. One of the key things, though, to recognize, we talked about this last year, and I think obviously the issues that made the news are really around this idea of microcephaly, which has to do brain development and head size. But what's been clearly shown since then is that the spectrum of injury to fetuses is much wider. Microcephaly is really the thing you see the easiest, see the most. But if you start looking at babies' retinas, if you start looking at other calcifications in the brain, we think probably some issues around learning development, that there's probably much, much greater impact of this virus on the fetus, on the developing fetus and the young infant than we kind of understood before. And so this is obviously the most devastating part of this. And I don't think we actually understand the full extent of it, nor will we for years to come as we try to figure this out. Many of the technologies needed to assess infants born after being exposed don't exist in many of the places that are also being infected. Things like MRI aren't done on everybody born, right? And who may have an asymptomatic pregnancy but had Zika and then infected their child. And so it's again something we're going to have to learn a lot more about in the future. But at least the connection between Zika and infection neural tissues is very clear, and the correlation with Zika infection and the injury to the babies is again very, very clear. I've heard some, obviously there's always people who say this isn't true or whatever, but it's pretty much done now, figured out.
Is there some reason why this epidemic happened after this not being a virus that we thought of or knew about for decades or forever?
Yeah, I mean, so we know that since its description in Sub-Saharan Africa, I think in 47, right around 1950, and the Zika virus in Uganda, that it did spread through much of Sub-Saharan Africa, but it appeared that there was a different variant that was associated with disease in Africa than the one we see spread across the Indian Ocean, moved into the South Asia. Then, really in the first big description in the South Pacific Islands, that did appear to be associated with many of the things we see now, so microcephaly, but also Guillain-Barré in adults. And what happened was, we think, and I haven't seen the updates on this, is that there was basically an infected person who I think is part of a sports team, traveled to South America, was viremic, was bitten by a mosquito, the right mosquito, and was able to transmit that. And you had, an entire continent of people who had no immune response to Zika. And so it just continued to spread. So you have no immunity, poverty, novel virus, right? And I think I showed you this last year. There was a map of predicted epidemic or emerging infectious diseases for 2015, 2016 across the globe. Had all these maps, right? Zika wasn't even like a footnote on that map. Again, going back to my first slide, the Lewis Carroll sort of effect on infectious diseases. No one knew that was coming, even though we had signals of it coming across the planet. And this is why I think, to some extent, viral forecasting is what people call it. Sort of looking what's coming out of animal populations, but also what's sort of percolating in human populations is actually very, very important for public health. Sometimes it kind of goes astray, but there's been really good work in, particularly, there's actually a doc here, Peter Rabinowitz, who's an occupational health doc.
He spoke last week.
Oh, did he?
Yeah.
Did he talk about his screening of animal workers in Africa? So Peter and I worked together on some of these projects, and I think that's important sort of work to do. We're actually going to Kenya next week to do some work.
I know there's a couple companies like Inovio working on vaccines. Do you think that's a viable approach, or would you just vaccinate, women of childbearing years, or given the fact that it's a benign illness for most other people?
Yeah, and so I guess there's two parts to that. Is that, I think there's great promise for vaccine. We know that once you get Zika, you're basically immune, it seems like. And so I think the vaccine's promising. Yes, who are you going to put it in? I think probably pregnant women is probably the most important group of people to do it with. And so the question then is, do you just vaccinate all pregnant women? Do you vaccinate women with no positive serologies, sort of like you screen them for like mumps or something else? Right. How that would play out. But I think I think we're going to see that in the next few years.
The primary cell type infected, and is the neurologic damage primary from the virus, or is it secondary to the immune response?
I'm almost sure it's primary to the virus, and all I know is it's neural tissue specific.
Specifically where the virus.
Yeah, specifically, and that was a very nice paper that came out, I think, in Nature in late spring last year. That was the first paper to actually show in vitro direct infection of neural cells. So it's taught us a lot. So this I just want to update you. So this is January 11, 2017. So last Wednesday, I think. This is Health Map, which is something I follow pretty closely. And these are the countries with confirmed local transmission. So again, we weren't talking about this a year and a half ago. And this is everywhere where Zika virus is transmitting. And some of those are travel associated. But I want to point out that last one down there. Vietnam reported 212 cases of Zika virus. So it came across the South Pacific. It's South America, Central America, the Caribbean area, Southern United States. And then it sort of moved back. And this is where, again, I'm a little out of my depth in this part. My understanding is that there's several variants of Zika virus. They're not immunologically variable, but they are, in terms of their pathology, appear to have some differences. And maybe this is part of that as you move back. Viruses, we know, are prone to all kinds of mutations, and it doesn't take much to sort of change the immune response to them and their pathological effect. We certainly saw that with Ebola virus. But so it's now this thing's kind of rebounding back. And I guess one concern to me, and I haven't talked to anyone with expertise in this area, is whether if this virus with this type of pathology moves back into Africa, what effect it could have. Very concerning. So this is the same health map, so you can go to this anytime. It's free, and you can do the whole world. It has, I'll just tell you, it has 1 billion dots of infectious diseases going on. This is Washington State. So those are all, this is January 11th last year. So all those dots, you know what they are? They're not Zika. They're influenza. Absolutely. So all those dots were influenza. And the national data on Washington State influenza is woefully behind. If you look at the CDC map, we're low, which is absolutely incorrect. The Portland area, most of Oregon is actually red, which is super high. And again, that border is not respected by influenza. This is the 2016-2017 respiratory enteric virus in Seattle, Washington. So our virology lab, you can just go to UW Virology Lab, click on it, and then it has a whole bunch of stuff, including respiratory. You can click on that, and there's actually a huge table beneath this, but this is just the graphical thing here. And you can look at all the positive tests they get. And let me wiggle this here. So you can see this light green line was, I thought it was rhino. Is it human metapneumovirus there?
Rhino. Yeah, that's rhino.
It's rhino, right? It should be rhino. That isn't, human metapneumovirus never gets that high. Sorry, I'm wiggling. There we go. Okay, so this is rhinovirus. You can see this brings us up through most of December. Right here, the red line is RSV, respiratory syncytial virus, which we know in the Seattle area tends to come up in January. This is a big deal, obviously, for babies and a big deal for immunocompromised populations. So SCCA, around the end of December, January, they start screening people very aggressively because this can kill people who are getting chemotherapy or have a bone marrow or solid organ transplant. And obviously, babies at children's hospitals is a big deal. So that's this. And this is actually, talking to my colleagues who do this work, this is a really high level, even though January we always see a spike. This is much higher than past years. But more notably is this incredible yellow vector here. So I am doing my best for this thing. It just doesn't like to do it. So is this yellow line, which is influenza A. So I took the week of Christmas to New Year's off, and everything was fine. And then like that Friday, it just exploded. And this is probably what you guys saw in the community. It just went crazy. And here's the testing from that week. It just skyrocketed. And this is why some of the national figures haven't caught up yet, because it was such a compressed and rapid expansion of influenza in our area. And again, influenza A being the big one here, and actually all but H3N2. So the end of that weekend, it just went pretty crazy. Tons of people sick over that holiday break. I talked to a lot of my friends like, how was your holiday? It was terrible. I was in bed the whole time. My kids were in bed the whole time. And this is cut off a little bit, but this is all of these, going back to 2009, 2010, this is Harborview inpatients. So every single one of these people had an influenza test. These are only inpatients at my hospital. And you can see here's all of the epidemics over the past, 8 years. And you can see here's the outlier is the 2009 epidemic, which we knew came early. Had that 2 waves. And what you see here in the red is the inpatients for that same time. So this is all, again, tested. These are all influenza A tested folks. And you can see, far exceeds every epidemic we've had for the past 7 years in terms of inpatient hospitalizations. So pretty impressive. Again, the rapidity of onset was incredible for us. And when at Harborview we're boarding anywhere between 30 and 50 people a day, and you just throw an extra 10 people, 15 people on top of that. We adapted, but it certainly made things a lot harder in terms of this. I'll also point out here, in 14-15, we had 61 hospitalizations, 3 deaths. 15-16, 45 hospitalizations, 3 deaths. That's the whole season. 2016-2017, we're 3 weeks in. This is actually updated last week, so this is January 4th, sorry. 44 hospitalizations, 3 deaths already. And part of this is also, we've actually had, I think, up to 10, as of this weekend, nosocomial transmissions. So people in the hospital for something else, getting influenza days into their hospitalization. And this might be to do with visitors, might be to do with roommates, it might be to do with healthcare workers. And that's a real struggle because we're getting 40 to 50 sick calls a day in a hospital, and your health workers don't like to skip work in general. They get the sniffles, and they're like, I'm fine, and they get a little fever, but I'm fine, and they're wearing a mask, and I'm like, don't do that. And then we get nosocomial transmissions. At most, usually we have no more than 1 a year. So this is really a big deal for us. So this is having a big impact, and I'll tell you, even though this number is, this is a big number for us, community hospitals, which serve older populations, so Harborview, our age is probably a little bit less than most hospitals. Community hospitals are feeling this even more.
And Providence Everett has canceled all elective surgeries because the whole hospital's full and they're boarding people in the ER.
Wow.
Yeah. So this, something like Providence Everett, which is already full all the time. Actually, Providence is a lot like Harborview nowadays in terms of neither of us have any room left. And you go to a community hospital which serves an older population, this is what you're dealing with. Smaller hospitals than us have 28 people in the hospital at any given time. We are about 20 per day, which is huge. There's a hospital in, I think, Pierce or South King County which declared a disaster. So they're going full incident command because they're not prepared to have people sleeping in the emergency room and staying there for their whole course. I had a patient yesterday or this weekend who spent 5 days in the PACU because there's no place to put them, right? And they got influenza. And one of the things is they're coming in with burns, they're coming with a car accident, they're coming in with, bacteremia from what have you, and influenza, right? Or they're coming from someplace else with a brain injury with influenza. And so it's really become quite widespread and very challenging. So I thought that was just impressive numbers. One of the things I just want to point out here, which is, again, kind of cool, I'm not sure if I'm totally nerding out here on you guys, putting you to sleep, but remember I talked, again, that Lewis Carroll stuff. Just think about those two things in your head. This is looking at the different types of influenza since 2010, 11, 12, 13. And each of the different colors is a different type of influenza. So influenza A is the influenza H3N2 is the red. The 2009 H1 is the orange, right? And then B is the green. And so just look at those colors. So if you look at each of these past few years, do you see a pattern? Nothing. And this is what's really fascinating about influenza. We're sitting here in the same place, right? Same population. Yes, we're throwing vaccines in this, but the population isn't vaccinated that well. We do get, obviously a lot of people get infected, but we know immunity to influenza wanes. But why is this happening? Why is this huge? And look at 2011 B, which technically is not something that we see that much of. It's typically right at the end of most influenza A epidemics every year. It kind of is the tail. You can see it down there in 2012 is pretty common. Kind of peaks after that. But look, it was the majority in 2011 and 12, and then totally switched over here. So we have a mix of B, H3N2, H1N1. Here's last year, 2014, 2015, H3N2. Same H3N2 that we're seeing now. So this is this week. The red is H3N2. Yet this year we're seeing a huge burden of infections. Lots of hospitalizations. I think it's going to be a pretty dangerous one. You already see we have 3 deaths. Usually in Washington State, I think we expect somewhere between 70 and 80 deaths from influenza per year, so we'll have to see what this one looks like. Fortunately, as of last week, I hadn't seen any pediatric deaths nationwide, but that always happens as a result of this. So I don't know why this is happening like this, and why is this the impact of the same virus in our population this year versus that year? So much to learn. Just fascinating.
You said an interesting thing. Earlier you said when you get Zika virus, basically your immunity is permanent.
Yeah.
You just said influenza immunity wanes.
Yeah.
Why are they different?
I think there's probably 2 things, and I'm not an expert in this area. I'm actually going to go into some of it a little bit, because there's some very nice papers over the last year to talk about this. One is that the kind of antigenic drift of influenza is fairly profound and good enough in that Red Queen hypothesis that it always is evolving past our immune response. So there's enough variation that's one thing. It's by our immune response. And the second thing is, for reasons that aren't entirely clear to me, our immune response to influenza wanes. It just doesn't stick around in a way that it does towards measles or hepatitis B or other similar viruses. And this is why when people talk about, the big people are really worried at the international level around emerging epidemics. Everyone, we talk about Ebola, we talk about Zika, we talk about, what have you. Influenza viruses are the ones that still scare people by far the most, and should, because of how unpredictable they are. And their ability to, our immune responses wane, the antigenic drift that we see every year, that minor changes that slide by, and then obviously the bigger events, which is antigenic shift, which is what happened with the 2009 chicken, pig, human virus that popped out in the American population and totally changed the face of influenza across the globe.
Do you know what the vaccine rates are in our state?
Exact numbers, I'm not 100% sure. It's less than 30% of most people get vaccinated. It depends on whether you're talking about kids and what part of the state. I always like to say Vashon Island, where one of the architects of smallpox eradication lives, is one of the areas with the lowest vaccination rates in the country. Yeah.
That sounds about right.
How about the antiviral drugs that is Tamiflu any?
Yeah, so oseltamivir, I think, does have a good impact. So, and I'll say two things. One, there's been, the data that is decent. It's in outpatients who are healthy adults. Giving it in the first couple of days probably saves you about a day or so. Probably, we think so. For at-risk people, we're extrapolating a little bit for pregnancy. Some of this is kind of a gamish of the H1N1 risk groups and the H3N2 risk groups. People with lung disease, diabetes, heart disease, other immunocompromised folks need to, I think, getting treated even after those 2 days probably is very helpful. What's really been interesting is that we've done a lot of prophylaxis, and it seems to be working. So that's something that, I'm getting a lot of experience, unfortunately, with doing right now. And when people get prophylaxed, they're not getting flu. And people who are missing prophylaxis with exposures that I know are happening are getting flu. So that's not so very scientific, but I can tell you as a frontline person, it seems to be working. And if I was early in my influenza, or my kids were early in influenza, or my wife, I would say take it.
What about resistance to?
So no documented resistance for the last couple of years. Last time we saw it in the United States or in Washington State was in the bone marrow transplant population. I think it was 2009 H1N1, and those people got oseltamivir for weeks and weeks and weeks. And we saw it there. There's been some more documented resistance in Japan, but I haven't seen any documented this year. We know with isolates looked at this year, zero resistance.
A couple of years ago, I read an article about developing a vaccine to sort of the invariable parts of H&N. I'm just wondering where that's headed.
So obviously the big deal about influenza, the H and N refers to hemagglutinin and neuraminidase, these two surface proteins that are involved with getting in and getting out of mammalian cells. And the big issue with our vaccines is that they're fairly antigenically specific. We don't know how good the vaccine is this year. I'll tell you again, just in my experience, and you guys probably have a shared experience, is that I have a lot of healthcare workers who are vaccinated. I know because I signed a thing that got them vaccinated. So I vaccinated about 5,000, 6,000 people per year. And a lot of them are getting influenza.
So that begs the question, should you be going on Tamiflu for the next 2 weeks?
Yeah, so
because I keep seeing all these people, and I'm going to be leaving in 10 days, and I don't want to get sick, so maybe I should be on Tamiflu.
So I'll say two things about that. So just so you guys know, I'm an infectious disease doctor. I run infection prevention at Harborview. I run employee health and antibiotic stewardship. So I'm kind of like a public health doctor for the Harborview campus, and so I get these questions a lot. And so I say two things. One is we don't actually know how the vaccine effectiveness. So how many clinic and inpatient hospitalizations does the vaccine prevent, like real world effect? We won't know that until about May. We know that the antigenic match is good. H3N2 appears to be matched to the vaccine H3N2 antigens that are in there. So that looks good. And usually when that goes together, it works out well. Now, but I have this sort of, data that I'm looking at every day where people are getting it who hadn't vaccinated. Now I'll say two things. One is, maybe it would have been worse without the vaccine. Right. I'm hoping. And the second thing is what I really strongly recommend. And typically when we see that good match, we tend not to prophylax everyone because otherwise I'd be just like tons of oseltamivir going out the door. We tend to only prophylax people who are not vaccinated in this type of season when there's a good match. Is that really, I think the key thing is washing your hands, and if anyone has the sniffles right now, any of your patients, get a mask on right away. As soon as they walk through, your front desk staff will be like, sniffles, mask. Anything more than that. Because I'll tell you, right now, if you're a healthy adult and you come in with the sniffles and maybe fever or muscle pain, it's not even worth testing. Right? We send, at Harborview, our PCR that gets sent, 40 to 50% of the tests are positive for influenza. So half of every test that's sent is positive. At that point, it is not worth testing because you have flu. Right? It's worth just, if it's early in your course, just treat you and go home. Don't waste the money. And the data actually shows that any time you get above 7%, the cost of the test is not worth it. And we're at 40 to 50% positive rate. So basically, anybody out there with the sniffles, just assume they have the flu right now. They may have some RSV. We've seen some of those cases, sure. But it's mostly the flu. Get a mask on. You don't want RSV either. Get a mask on them. Wash your hands. And you should be actually good. So the idea is to prevent exposures. Now, can you have it out in the world? Just don't put it in. Get a mask on out there.
That's right.
Yes.
Since we know with other viral vaccines like hepatitis that you need 3 to get adequate vaccination, has there been any experiments with a second?
That's a great question that just came up. Again, actually, a colleague of mine came up with this. So as far as I know, please correct me if I'm wrong, anyone in the audience, I haven't seen any data on serial vaccination for influenza. It may be out there. What we do have is high-dose influenza vaccine. So right now there's a lot of choices with influenza vaccine. There's trivalent, quadrivalent, but there's also a trivalent high dose, which is something, I forget what the exact 10-fold greater amount of antigen, and a vaccine for folks who are 65 years and older. We know as we get older, our ability to mount an immune response to a vaccine challenge wanes. And there's good data now for that high dose that the immune responses are better, so the titers are better in older adults. And the number of influenza-like illnesses and confirmed influenza infections in those patients is fewer. So right now at my hospital, I recommend folks 65 and older to get the high dose. So there appears to be an antigen dose immune response match. And so it may be that would sort of lend support to the idea that more antigen is necessary.
It's just, I got into it with Po2, who's one of our doctors who's into this, and I asked him, why don't we vaccinate people a second time? He goes, there's no data.
There isn't.
But there is for all the other viral vaccines.
Yes.
So it just seems like there's a disconnect there.
Yes.
And he's talking about all our walk-in doctors who are catching the flu that were all vaccinated. And
yes.
So why don't we try something different? And
yes. I think it's great. I think it's a worthwhile idea. Or just giving everyone the high dose.
Yeah, exactly.
I think it's, yeah. I do not speak for the entire infectious research community, but
we can quote you when you say
you can quote me. I think it's a good idea.
All right.
Yeah. So here's the other thing. So I think all the points you guys are making are absolutely valid, and I think are definitely worthy of investigation. One of the big issues, though, with high dose, repeated dose, is that it changes every year. The drift, red queen hypothesis issue. So one of the things that people are really interested in is can we make plus you have to predict, right? So the vaccine for this year was predicted back in February of last year, looking at the southern hemisphere viruses that circulating. Sometimes it works. 3 years ago, it didn't work at all. And so in a vaccine that actually isn't that super good, as you're pointing out, right? Even when it's good, it's not great. So people are really interested, and then you have to do it again every year. Big, huge churn. So people are very interested in how can we make a vaccine that hits every virus, so we don't have to predict anymore, and maybe has longer lasting response. So the issue is the hemagglutinin and neuraminidase, the H's and N's, the 3's, the 2's, all that stuff, right? That changes constantly. They're always shifting. They're always drifting, and then there's always the potential for shift. And the problem is that the things that are ultra conserved, in most cases, the things that researchers are targeting are the hemagglutinin stem. So it's kind of like a mushroom with a stem attached to the viral envelope. And that is super conserved across all the influenza viruses. But most of the antibodies we find out there, they either are generated in a lab or found in people or in animals, just aren't that potent. So you have this super conserved area that if you could target it, that'd be awesome. But the antibodies that people have found just haven't been that good to that area. But that would be the idea. This group was actually from a pharmaceutical company, but it's a really cool paper. I mean, if you like any of this stuff, these guys just went at it. They did just a ton of work. It's really quite beautiful work. What they did is they actually found a human being who had these really interesting neutralizing antibody responses to influenza. They extracted some blood, got the B cells. Oh, geez, sorry. That's right here. That's my electronic portable pointer. Runs on solar. They extracted B cells, and they isolated actually 4 different antibodies. This is one, FY1. And it has this really interesting heavy chain variable region called VH61. They did a whole bunch of cool mutagenesis. They isolated what's called, I think, the unmutated common ancestor of these 4. So they did all this really cool mutagenesis work. And they were able to show that these different ones, and here the focus is on this one, they isolated F11, was very effective against both group 1 and group 2 influenza viruses. You can see they're blue and red. I won't go into the reasons of those. They did some really cool things. They got rid of kind of all the junk DNA that made this antibody. Anything that was potentially be susceptible to additional mutagenesis, that sort of shift within the germline. And they were able to tune it up. And again, I'm trying to make this work. There it is. Is that this is viral titers. This is the first round. There's blues and reds, the group 1 and group 2. They did all this cool mutagenesis work. They made this new one called MEDI8852, this antibody, and it made it a bit more potent against virus. They put this in a germline, did some really cool in vitro affinity maturation. They did some beautiful crystallography. If you like that stuff, the picture's amazing. They showed where the influenza stem binds in this antibody. And I'm sorry you can't see it down here, but they basically tested this new antibody, 8852. They did plus minus also oseltamivir, and they did it in mice and ferrets. They haven't done the human stuff, and I'll just show you some of the mice and ferret data. So the idea here is that this is an antibody that they sort of got from a human. They tuned it up in the lab. Did some really cool stuff, and they showed that it's highly effective against basically all influenza viruses, all the HS1s. I'll go through this quickly because I only got to see. I actually did fewer slides, like way fewer slides today. And I'll just go quickly here, but this is the first 3 on the left are mice. The bottom one is ferrets. And on the left is mortality, Kaplan-Meier curves. On the right is virus titer. So the top one, I keep trying to do this.
Ooh, I thought we were going to get a new computer. It's been on my list.
This is just, milligrams per kilogram. So high dose is red. Basically, if you give this new antibody to this is a lethal challenge for these mice. These are BALC mice. You give them the virus, 100% die. Here, 100% live if you give them high doses. And this is against the 2009 H1. Here's H3. Again, if you give them early, this is 10 milligrams per kilogram, which up here is higher than this 3 milligrams per kilogram. You give it to them on day 1, 100% of them live. Day 2, 100% of them live. I think day 3, 100% of them live. Again, a lethal challenge against a different virus. And you can look at the titers of virus in the lung. So they just take the whole lungs of the mice, grind them up, and look at the titers. And you can see that they're associated quite closely with the amount of antibody they get. And then down here at the bottom right, this is kind of just an interesting thing. They looked at temperatures in ferrets, which are pretty consistent. That's the dotted line there. And if you give ferrets this, you can see over here early, this MEDI8812, it actually keeps their temperatures pretty close to normal for the entire duration. If you give them oseltamivir at the bottom right there, their temperatures actually do spike. It doesn't have any effect at all on their temperatures. So we're looking here as an antibody that appears to be effective against all of the influenza viruses, at least in animals, right? One antibody that hits them all. Pretty amazing. And this one can be manufactured. For those of you who don't do antibody stuff, the manufacturing of antibodies right now is like at this incredible, what's the right term, era, where we did the potential, even here in Seattle, for making low-cost antibodies at very high concentrations is like right there. There's some really cool work going on right now where this is going to be. This isn't something that could never be done. This is something that potentially antibodies used for infectious disease more commonly is a potential. This is quickly go through these. This is the hemagglutinin stem. This is from an older paper. This one just came out in December. This came out from a year or so ago. This is looking at nanoparticles. But again, they're able to use hemagglutinin stem. Remember, that's the ultra-conserved part of that hemagglutinin. They use these nanoparticles, and they were able to show that there was cross-reactivity. So they used an H1 nanoparticle, but it was effective in all these challenges for H5. Again, totally separate influenza groups, H5 versus H1. This H5 doesn't really infect humans, H1 definitely does. And they were able to show these nanoparticles were able to provide potent immune responses that led to stable body weights and improved survival. I'm going to go just quickly through this. And I'm just going to skip back, I'll just talk really quickly. This is just showing that there is some signal there. This is looking at serum from humans that are vaccinated against H1N1. They take that serum, they put it into mice, and they give it a lethal challenge with H5. And what's really cool is that this is H1N1 at the top and H5N1 at the bottom, so a completely mismatched virus. Yet the human serum appears to have some, not great, but some protective effect. So the idea is that even though we're getting immunized, and we always focus on this antigenic perfect match, there appears to be a little bit of, for lack of a better word, sort of overlap or messiness in our immune response that maybe means that the vaccines are in some ways more potent than we think. We just need to find a way to make them more clinically effective. But it's there.
Question. Earlier you corrected yourself on the word shift and drift.
Yes.
As if that's a big point.
It's huge.
It's huge. You want to clarify that?
Sure. Sorry if I glanced over that. So these are RNA viruses. They have 8 RNA subsegments in them. And in many ways they're simple. And RNA viruses have horrible replication fidelity management. So they're continuously mutating. Many particles are not functional, but as a result, they're able to make lots of mistakes and mutate. And a lot of times they're making mutants that are ineffective, but sometimes they make mutants that are effective, and they can sort of evolve through time. So an H3N2 maybe from last year is going to be maybe slightly different this year because they've made minor genetic variations over that last year. So that's called drift. They're just drifting through time, making all these little changes. What happens with shift is you take an H3N2 and an H1N1, and they get into a single animal that can be infected with both. Most commonly used for research are pigs. Pigs can get an avian influenza virus, and they can get a human influenza virus. Because they have 8 RNA subsegments, you can have the same cell can get infected with 2 different influenza viruses. And those RNAs get recombined, and the next thing you know, instead of having an H3N2 or an H1N1, now you have an H1N2, right? And that pops out. That's a brand new virus. And when that happens in the population, like the 2009 H1N1, we don't have any immune response to it. We covered the human one. We didn't get infected with the avian one, but now we have a brand new one that gets in the humans. And that's when the whole population has no response, no immune response. It's like Zika in South America, except that it's respiratory. And it blows through the population. So that's called shift. And that's what everyone's very worried about. Because these things recombine in animals. They're zoonotic. Influenza viruses are zoonotic. They go into animals, out of animals, pigs, avian, birds, chickens, ducks, everyone, and humans. And they're recombining, and particularly in the pig populations, but also in bird populations. And then they're getting, when they recombine and pop out in humans in new forms, that's what's the big concern. I just want to, on a kind of a high note here, I got 5 minutes left, talk about vaccine, Ebola vaccine, final trial results. This is a WHO, and many other folks who are leading this. This came out in December. Ebola vaccine is highly protective against the deadly virus, which is fantastic. This is really, really good news. This is a trial involving almost 12,000 people in Guinea during 2015. Among the 5,837 people who received the vaccine, 0 cases of Ebola reported 10 days or more after vaccination. So that's great. No ongoing outbreaks, fairly sporadic right now. Again, going back to the Lewis Carroll contribution, we don't know what's going to happen. But this is incredible. Now the question is, what's the next step? Who gets it? And who doesn't? The last part about Ebola I just want to point out is that we talked about, I might have mentioned this last year, is that the longevity of Ebola in people is still unknown. We know that it appeared to stay in semen for months after infection, but these are some of the numbers that just came out in a paper that, in the last couple of weeks. First confirmed report of a person without obvious Ebola virus infecting another person. This is a healthy mom, passed the virus to her 9-month-old daughter in breast milk, and the baby died as a result of that infection. So, fine. And again, the spectrum of Ebola, I think, is much broader than we appreciate. Maybe it's more like dengue and Zika. There's people without symptoms or without severe symptoms. And then here's another one. People who became infected during the recent outbreak escape detection tracked 80 people who had contact with Ebola patients but did not themselves become ill, yet 15-20% of these contacts had immune responses. That they probably had mild infections that were undetected. And here's another one. Here's a sexual transmission 17 months after recovering from this infection. That's almost 2 years. And semen within 4 months. So that's probably an outlier. Here's one that's more than 18 months in semen. So again, the spectrum of disease is unknown. And this is just using a ZMAP. This is I think it's a cocktail of monoclonal antibodies, which this is a randomized control trial that came out last year and showed that it actually wasn't statistically significant difference in terms of treatment of Ebola patients. I'm going to end on this one. Jeez, you guys keep me talking too much. Okay, I'll keep going. So I will say this is as I said, one of my things is antibiotic stewardship, so controlling antibiotic usage in hospitals so it's rational and improves patient outcomes and patient safety. And so we're always, in pretty much every infectious disease, and I've said this joke before, there's only 2 things infectious disease docs don't know. Which drug and for how long, right? And we always, every trial we've ever done, though, appears that shorter courses work. Pneumonia, urinary tract infections, shorter course antibiotics work every time, until this one. The current recommendations for otitis media in young children is 10 days. And this research group wanted to see whether 5 days was sufficient. Again, every study that we've done shows that shorter courses of antibiotics work just as well as longer courses. And what they showed here, looking at different measures of symptomatic response over here, is that the 5-day group didn't do as well as the longer treatment group. And every single measure was almost except for the top one there, the score, was statistically significant. Sorry, you can't see the bottom. I think it's 0.02, next one down there. So if you look at the clinical failures, children clinical success, and to some extent the SOS score, longer courses of treatment actually were superior. And so this is one of the first trials I've actually shown, that I've seen, that shows that longer courses of antibiotics in a very, 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 very common disease are superior. So the guidelines are probably the right way to go right now. Interestingly, they also did some looking at nasopharyngeal carriage of whether there's any resistant strep pneumo. They saw no differences in either, because that's one of the big concerns we've had. And interesting, the clinical failure rates were greater in children who were exposed to 3 or more children for 10 hours or more per week, and in children with bilateral otitis media. So anybody who has a child in daycare, your failure rates for otitis media, even with 10 days, is going to be much higher. And that's just the way it is. You just probably getting exposed to the same stuff over and over again, or different stuff. Okay, I am going to stop there rather than going to... So I know where to pick up next year. So every year I'm going to just end with something that I can just pick up on next year so that it's kind of like one just continuous flowing talk for 7 years in a row. So I'll pick up on this slide next year. Is that okay?
Well, how about this woman in Nevada who died of...
Yeah, so I told you about this guy, David Ricci, if you guys want to stay for just 2 minutes. David Ricci is a patient I took care of years ago who had 5 or 6 bacteria growing out of his surgical and trauma wound. This is just 2 of them. All those R's. This just came out. There's the date, January 12th. A woman dies of a superbug resistant to every available antibiotic in the United States. They tested against 26 different antibiotics, and nothing was. I can't figure out. I've looked at a lot of sources. I can't figure out what she died with exactly. We know this was in her, I think at least in her urine, maybe her gut. It was a Klebsiella pneumoniae. She had spent time in India, a fair amount of time, including in healthcare. But this is not what you want to see. This is why we're worried about giving people 10 days of antibiotics, right? And we're worried about nasopharyngeal carriage of resistant strep pneumo, which actually Poe's got great data on. That those community hospitals out there are seeing fairly high rates. 10, 15, 20% of strep pneumo is resistant to penicillin. So that's a big deal. This is where we're going to be going unless we are cautious about all these things. And I'll just say, we talked about this last year, this MCR1, and right after I finished talking to you guys last year, I don't think much after that, this MCR1, the apocalypse pig one, this one, it was described in China, appeared in the United States. This was in May of last year. And now there's been, 7 cases in both humans and animals since then. So as soon as these things are reported some place in the world, it's months before they're in the United States. So the David Ricci case, that woman with the Klebsiella pneumoniae who came from India, They actually screened about 20 or so people around her. Unfortunately, found no transmissions. These cases are popping up. This first one, no contact with anyone outside the world, but heavy healthcare contact. No idea where it came from. I was going to show you this video, so maybe I'll start with this video next year because it's about microbial evolution, which is really cool, and I don't want to skip it because it's worth it. You have a slide, so go look at it sometime if you want, but I can start with that next year because it kind of brings us full circle back to where I started with the Lewis Carroll stuff.
You talked about the virus, it's the multivirus stem that you can vaccinate to, but were you giving those patients antibodies against that, or were you vaccinating them against that?
So in the nanoparticle one, they were vaccinating.
The one before that.
That was antibodies. So the idea was you have an antibody that you give to people with influenza. Right, passive immunity.
So it's like IgG for prophylaxis.
It is, but it's more like on the rituximab, sort of like I can stick it. It's a specific target.
Right, but it's going to give them 6 weeks of protection, and then it's going to be gone.
Yep.
So have they tried vaccinating with that?
I don't think that no one's been able to. So there's some antigens that are able to. That nanoparticle one is an attempt to do a vaccine that does the same thing. So this one,
right?
That one it does against the stem. So the SS is stable stem. And these are nanoparticles which elicit antibody responses to that specific area. So I think we have to figure out whether it's going to be, is it going to be antibodies to treatment? Or and the issue is treatment versus vaccination. Maybe we need both.
Is there a study going on where you vaccinate people with this to see if they ever get the flu?
So I don't know if this one has been done in humans yet.
Okay.
I haven't seen any of these in humans yet. I know that this one is headed to humans, clinical trials. This is a company. They want to make this. And this one is, I think, is also. I'm sorry, not this one. This one is, I think, is also a company. There's some other folks in there, but they want to use this as a vaccine. This is a novel antigenic presentation of these nanoparticles. They're self-forming nanoparticles that present the stem in this sort of stable format that elicits antibody responses to that very conserved area of influenza.
And last question: has anybody thought about vaccinating the pigs?
Actually, I think so. Yeah. So if you talk to Peter may have talked about this, but if you go to a farmer, they care. They're that's money on the hoof, and they care a lot about their animals, and they do a lot of vaccines for their animals. Actually, animal vaccinology is far ahead of human vaccinology. There's anti-cancer vaccines that are used in cattle and pigs that we don't use in humans that are very effective. They do a lot for their animals. Now, some of that has bad outcomes in terms, especially around the drug resistance areas. But in general, they take very good care of their animals because they want them to.
But you think if you could get the stable stem vaccine in the pigs, then they couldn't replicate the new viruses?
Yeah, the problem is that there's a lot of pigs in the world, and actually, I think I showed you this data a few years ago. If you look at the number of commercial kind of congregate animal settings, so the number of farms in the world is dropping dramatically, but the number of pigs and chickens is growing astronomically. And what that means is that the U.S. European version of congregate industrialized agriculture, animal agriculture, is exploding around the world. And how do you get to all of those animals is a huge question because it does cost, one, money. It costs money, and two, for what is a rare but incredibly meaningful event, right? Like, if I was a Mexican farmer in 2009, I wouldn't even I said, oh, there's this virus, I want to vaccinate pigs. I'm like, why would I do that in Mexico? Because everyone's looking at South Asia for the next virus. Yet, where did it come from? And so, money-wise, yeah, it made no sense to vaccinate them. But that's where it came from. So you'd have to hit, like, every pig in the world.
That's not going to happen.
That's not going to happen.
No.
Well,
so thanks for your attention.
Thanks for another brilliant call.
Oh, yeah.
Pleasure to have you every year.
Yeah, it's awesome to have you.
Yeah, I thought that I was going to not have enough. I thought it was going to be like 15 minutes.
Well, we interrupt you all.
No, I love it. I mean, actually, how are you? Happy to be here.
Bill Gates' comment is that the next world disaster is not nuclear war or famine. He says it's going to be that's his biggest concern for the future. Is that something coming out of his foundation, or is he just extrapolating?
I think he's extrapolating. I think everyone's worried.
Is anything left in there?
Yeah, I think
probably want me to take
You
it
know,
to
there's a
the
lot of
clinic.
yes, but you know, the people, there seems to be enough balance. There's a balance around.
I mean, not great.
Great that we have it. So, now it'd be good to chat. It may also be useful. I mean, I can be our nurse, which is all of our sort of like biologic type drugs, and maybe.
But you said you can take it
as well.
I can take it.
Okay.
Okay. Cool.
Pack it up.
You look at every new virus.
You have to go
in the last 10 to 15 years. They've all been to the right SARS.
Do I send you your email again?
Those are all coming out of it. And what are we doing as a population moving? I remember.